Hello everyone, welcome to JBotAI. In this video, we'll talk about types of machine learning. Imagine three friends walk into a restaurant for dinner. Let's meet them. The first one is supervised learner, second is unsupervised learner, third is reinforcement learner. Meet our supervised learner friend. She gets a food menu. She looked into the menu and she saw paneer tikka and its ingredients and its diet type, and also butter chicken, spinach curry, all those things. So in this menu, everything is like dish and its ingredients and its label, means a diet type format. So here dish is paneer tikka and its features or ingredients are paneer, spinach, cream, and the label is vegetarian. So easily she understood the pattern after seeing the menu. So dishes with a dairy but no meat is called as vegetarian. Dishes with any kind of meat is called a non-veg type. Dishes without meat or a dairy often lead to a vegan label. She got a conclusion that these are the format they have maintained to discriminate various diet types. When she gets a new food, that's green power bowl, which she has not seen in the menu, she don't have any idea about what diet type it is. So she saw a tofu on it, spinach or quinoa on it. No information about meat or dairy in the bowl. So she sees all the ingredients and compares them with a pattern she already learned while seeing the menu. Then she easily came to the conclusion that, okay, so tofu, yes. Spinach, quinoa, yes. So no dairy or no meat, yes. So that means if all the checklist is okay, that means maybe it is of vegan type. So she made a conclusion based on the previous information she learned. That's exactly what supervised learning does. It learns from examples with the right answer and then predicts the answers when the label is not there. We train a model or an algorithm using data that already has the right answers, just like that girl learned from labeled dishes, right, in our previous example, similar to that. Once the model has seen enough examples, it can guess the label for something new. Like the girl, she guessed the green power bowl based on the information she learned from the menu. So similar to that. Supervised learning has two types: regression, classification. It's nothing but different ways of learning. Some can learn to predict numbers and some are good in grouping. It's similar to that. Regression is for predicting the numbers and it finds the relationship between inputs and the labels or output. Example for this is house price prediction, predicting the price of the house based on the square feet, how many bedrooms, how many bathrooms, or all those the features. So predicting the house price is one of the example for regression. When it comes to the classification, it decides whether something belongs to this group or that group. Its kind of output is like binary, either true or false, or either 0 or 1, or also multi-class classification. So if you have three groups, so whether this particular image belongs to which group, whether this is apple group or banana group or orange group, like that. So example for this may be of email, whether it's predicting the email is spam or not, or diet type, what we have seen in the beginning of my video. That's a perfect example for classification. Identifying whether the food is vegan, veg or non-veg type. That's a perfect example for classification. This is the use case for regression type supervised machine learning. House price prediction, predicting the price of the house based on other features. Here the features are size of the house, bedroom, bathrooms, and where it is located, all other features. And based on these informations, machine should predict the price of the house. So when we fed this data into the model, this will be converted into the vectorized format and then it's fed into a respective algorithm, and the algorithm finds the relationship between the features and also a label. So the relationship we can see here is a size and the price. As the size of the house increases, price also increases. So based on these relationships, algorithms predict the price of the house. and also a diet type prediction. This is the best example for a classification type of machine learning. So here the data set has dish names and all those ingredients what we have seen in the menu. Those are all different features and also a diet type. When we fed this into a machine learning algorithm, this will be converted into a vectorized format, and then it finds the relationship between a diet type and also other ingredients. It likes makes the check mark. Okay, broccoli is there. Okay, make it as 1. Tofu 1. So it finds the pattern on it. It's a classification problem, right? So it finds the pattern on it and it decides in which group this belongs to. Meet our one more friend, unsupervised learner. She gets a food menu that's empty. There is nothing here. So how will she order? How will she decide what to eat? The waiter just bought many food items. How will she decide whether it's veg or non-veg or vegan type? She just started looking for patterns on it. So the first dishes looks like green and full of vegetables on it, and the second one is like vegetables and also like meat smell on it, and also the third one looks like avocado, some cream on it. Maybe it's a vegan type. She will decide like that. So even though no one told her what it is, she started grouping similar dishes together, like all the vegetables. Okay, maybe it's vegetarian, non-vegetarian, or vegan type. Here there is no right or wrong answer in deciding here in this particular topic. Just grouping a bunch of data, and the system tries to find a pattern on its own. In simple terms, it's like organizing clothes by color or songs by vibe, right? Even if you don't know the names of the categories yet, we'll just organize based on the color or based on the vibe of the song. No labels, just patterns. That's what unsupervised learning does. In unsupervised learning, the algorithm is given input data, but there is no labels. Algorithms discover patterns, grouping, or structures in the data all on its own. The example for this is email spam or not spam. That's the best example for unsupervised learning. There is a subject line, win a free vacation, meeting agenda. All those are the subject line. When we feed this data into the model, so what happens is it will just identify, okay, whether it has a link. Yes. If it has a link in the subject, maybe it is a spam email. Whether it contains a free word on it, maybe it is of spam type. So these kind of analysis a model does. So then finally it decides whether the particular email is spam or not by identifying it as 1 or 0. If it is spam, it identifies as 1. If it is not spam, it identifies as 0. Suppose if the model is fed with this data, along with this, if we fed the result label, suppose take an example like we feed the entire this set into the model, that becomes a supervised machine learning because we are feeding features and also a label on it. So that means that's a supervised learning. If we feed only this much without this table, that is unsupervised machine learning. Meet our one more friend, reinforcement learner. She went into a buffet, so that's why she doesn't have any menu at all. She don't have any idea about what food it is and how it tastes. What she'll do, how she decides what to eat, she just tastes all the dishes. Every time she tastes dishes, she gets a feedback out of it. Oh, this is good. Oh, this is bad, like that. That helps her learn what to pick next time. That's what reinforcement learning does. Where an agent learns through trial and error, aiming for the biggest reward. So for example, reinforcement learning is used in self-driving cars, where learns to navigate traffic, avoiding obstacles, and follow rules by receiving rewards for safe driving and penalties for mistakes. And recommendation systems, Netflix, Amazon, Spotify, it learns based on our clicks and based on our views and based on our purchases. It's make a conclusion that, oh, they like this, that, like that. This is used in robotics field as well, so learns to pick up, place or assemble objects by trial and error. So it improves precision over time as well. That brings us to the end of this video. We learned supervised learning, where machines learn from labeled data, unsupervised learning, where patterns emerge from chaos, and finally to reinforcement learning, where agents learn by trial and error and reward. Thank you for watching. If you found this helpful, give it a big thumbs up, share it with your fellow learners, and don't forget to subscribe for more intuitive explanations like this. Thank you for watching.